Hello, welcome to RCR AI TechTalk, and I'm your host, Susana Schwartz. And today I'm talking to David Driggers, the CEO and founder of Cirrascale. Hello, David. How are you?
I'm doing well, thank you.
Maybe you could just start off by telling us a little bit about Cirrascale and what makes you unique before we get into the questions.
So we've been put into the bucket of neoclouds, and which in general, we used to call it being a boutique cloud provider, not a
Right.
hyperscaler. Now the term neocloud seems to be sticking, but we're very different than most neoclouds. Yes, we're not a hyperscaler, but we're not new. I think one of the main reasons why people call this tier two of neoclouds is that most of them are newer. We've been around for a long time. We come from a deep hardware background. We were a server manufacturer and designed and built the servers, frankly, that are now really driving the AI revolution. We invented the 8 GPU server in 2012. So when I say we're not new, we've been doing this for a long time.
Right. And what is it that the value proposition in terms of what's happening with AI right now? I know that there's, in terms of AI accelerators and alternatives to NVIDIA, is that where you come into play as you kind of give an alternative to what's out there?
One, we certainly embrace NVIDIA. They dominate our training platform. We have three main types of offerings: dedicated training platforms, dedicated inferencing platforms, and then our inference as a service. And when it comes to
Okay.
dedicated training, the vast majority of our training platform is NVIDIA based.
Okay.
NVIDIA is kind of the easy button there. You use their GPUs, their networking, their software stack. You've got a turnkey, one throat to choke solution, and
Okay.
it's fantastic for doing that. Just a little expensive, but it's still the best training platform out there. But yes,
Okay.
we do embrace other accelerators. We always have.
Okay.
That 8 GPU box we built first with NVIDIA. 6 months later, we did the same thing with AMD back in 2012. So we've
Okay.
always worked with multiple accelerators. We've also believed that especially when we move into inference, there's more horses for courses type scenario. With the current generation of AI, which is the third major wave, the model delta, the size from the smallest usable models to the largest usable models, it's orders of magnitude. It used
Okay.
to, with an auto, it all fit within a single order. The biggest and the smallest models were actually pretty close to each other. Now
Right.
we've got billion parameter models that are usable in AI for Gen AI and for LLMs, all the way into multi-trillion parameter models. So the different model sizes is tremendous. And that makes it where there's not a one size fits all from an accelerator perspective.
Okay.
And it's going to get worse as we move to a mixture of experts and move to multimodal type inferencing, where you may be integrating audio, video, plus text, and ultimately spatial. Different accelerators are going to excel at certain parts of this and not at
Oh,
others.
can you dive into that a little bit? Like, can you give an example of
Sure,
what you mean
sure.
by that?
So, if we all believe Jensen, you'd just buy the biggest, baddest thing he has, and it would be the best value. It really
Right, right.
isn't. When you move into inferencing, you really you want the smallest unit that your model fits into, as long as it's smallest simple unit. And
Right.
then once you can fit into that unit, you want to push it down the technology stack as far as you can go, where you still meet your latency requirements, so your time to first token. And the reason
Okay.
why is semiconductor companies, and it's not just NVIDIA, every semiconductor company, Intel, Qualcomm, AMD, NVIDIA, the higher you move up their technology stack, the
Yeah.
more they charge you per flop, and most importantly for inferencing, per megabyte of memory. So you
Okay.
want to push it down, both the performance and the memory stack, as far as you can go to where you still hit your latency. If you get too low, you got to step back up. Or if it doesn't fit on one GPU, you have to split your job across two, and you lose an awful lot of efficiency.
Hmm.
When time to token, you got to hit the latency requirement. That's full stop. But
Yeah.
the next is usually the more you have to split your model, the more inefficient it is, the more difficult it is to deploy. So in general, you want to find the smallest unit you fit into, the whole model fits, where you hit your latency, and that'll give you your best cost. And
Okay.
with inferencing, you're in production. Now once you hit your speed, the required speed, from then on, it's all about cost. What's my cost per token? It may be, if you don't push it down, it may be that it's too cost prohibitive to even run. And here
Right.
you've done all this work training a model or building a RAG or fine tuning it, and then it's too expensive to run if you don't get the right platform. if it's a profit center for you, saving
Right.
10% may double your net margin. If you can drop an extra 10 points and you're only making 10, you double your margin. So for
Right.
inferencing, it really does matter to get the right, like I say, the right horse for the right course.
Right.
If you need a big model, you're going to have to have a big platform. If that time to first token is mission critical, you'll choose a platform that is all about how fast can I get that first token. I mean, we just saw NVIDIA buy Grok or do some weird investment into Grok where they effectively are in effect are buying them. And that was for a type of workload that NVIDIA is not ideal for.
Right.
Cerebras has done really well. Same thing there for really high frequency. I've got to have that token like now. It costs a lot more, but it's necessary for the actual use case.
Right. And in terms of use cases and that time to token, that urgent mission critical type of thing, are you seeing, what would be some of the use cases that you're seeing or that you think will come in this 2026? With the shift from training to inferencing, do you think that,
It's
can you name a few?
all over the place. So if we don't worry about time to first token and we're doing what we would typically call either offline or batch processing, like say we're processing a PDF or a form, I don't need that PDF
Right
OCR
away.
immediately. I
Right.
want it done as cost effective as I can. So
Right.
especially if I'm processing a lot of forms, it's all about having the ability to scale still within a time frame. If I've got to
Right.
get these forms processed over a weekend, and that's my time frame. They've got to be processed on Friday. They got to be ready on Monday. We take that
Right.
into account, but that means I'm not looking for how fast. I'm trying to figure out how I can get the cost down and how I can process as many forms as possible within that time window. If it's a chatbot, same thing there. It's now we move into something that's more near time. I can't wait. I can't type something out on Friday and get my answer on Saturday or Sunday, but maybe I don't need it immediately. Now, if
Right.
I'm trying to do fact checking,
Right.
real-time fact checking, if it takes me too long, I won't be able to do it right in a real-time type scenario.
Right.
Same thing if I'm trying to filter. Say I'm trying to filter out child pornography and I don't want it to go out. I'm trying to filter before I run the LLM. I'm trying to make sure what's being typed in is not something that I don't want to allow into my model.
Right.
So those are where you got true real time, and it needs to be very, very fast and maybe extremely scalable if we're trying to do threat detection. Because once the virus is in, it's too late.
Right.
Once the bad actor has broken your security, it's too late.
Right.
So,
Right.
but being able to find the fraud detection if you're doing credit card processing, you want to find it immediately because the person's standing there trying to spend money.
Right. And is your focus because of your history and your background in hardware, does that give you an advantage maybe to someone who's more focused
Absolutely.
on software,
Absolutely.
their
So,
bare metal aspects and
yeah,
so
since
forth?
we've been doing hardware forever and we've been doing multiple platforms forever. So we really understand the differences and the nuances of where the hardware ideally fits. And then we actually get into the model. So our inference as a service, we actually take the model from the client and we run it. We work with them to come up with what is their SLA. Do you have a time first token? Do you have a regional latency challenge? So the bigger the problem, where it's a real-time application that's following the sun from East
Yeah.
Coast to West Coast, perhaps even into Asia and into Europe.
Yeah.
We help the customer understand what the SLA requirements are. We run the model. We test the model and figure out what's the best platform for it to go on. We don't require them to figure that out. And then we say, here's the price per token to meet your SLA. And like I
Okay.
say, is it real time? Is it near time? Or is it batch offload?
Right.
So, because the way we run the model is different. If
Right.
it's highly latency sensitive, we may be only running it one job per time in a
Right.
serial fashion. If it's near time, we're probably putting in multiple people because while you're typing, until you finish typing and when you hit enter, other
Right.
people may be doing that. So that'll be more near time. Whereas
Right.
batch, I may be shoving a ton of these in because I can cache them. I may be running 100 sessions at the same time because I can get more slow tokens, more total tokens, because the GPU is constantly busy or the accelerator is constantly busy. But yet
Right.
that time between sessions is wider. That guaranteed answer, that time to token is, since it's spread, I don't have a guarantee. So we run it for them. We determine what their token cost should be based upon what their SLA is.
Right. Okay. And in terms of the customers you work with, I mean, is it mostly, mid-size
So
enterprises, or are you also working with hyperscalers, or can you give me a
it
little
depends
sense of,
upon,
of who your customers are?
so we've got the three products: dedicated training, dedicated inference, and inference as a service. And frankly, the what we call the ICP is different between those product offerings. For training, we work with well-funded startups who are in later stages of their development where they're trying to scale. They don't want
Right.
to have an IT department. They're born in the cloud. They're cloud, what I think people are calling cloud native. They want to live and die in the cloud. And
Right.
so well-funded startups tend to be one of our main targets for our training platforms. The other one is research. So large research institutions. I mean, we worked with OpenAI until from 8 people until Microsoft gave them $1 billion. And then
Okay.
we lost them. So we currently, one of our biggest customers and biggest partners is AI2, the
Hmm.
Allen Institute of Artificial Intelligence. Paul
Okay.
Allen's kind of his dream of replacing OpenAI and keeping it
Right.
completely open. So all they
Right.
do is train models. But
Okay.
because they're a nonprofit and a research institution, a lot of their funding has rules around it.
Right.
And they're allowed X amount of the funding to be CapEx, X amount of the funding to be OpEx, X amount of the
Right.
funding to be people,
Okay.
labor that they may have to create a certain number of jobs. We're unique definitely within hyperscalers and also within most of the neoclouds in that we allow our customers to own some of the equipment if they want to. So
Okay.
we can leverage that part and then we turn it into a cloud service for them. Normally they're buying the platform from us. We don't look at that as a profit center. So we can
Hmm.
typically sell them the equipment at a very low margin. No one's going to make money off of Jensen's hardware. That's just how it goes. He makes the majority of the profit. We don't. No other cloud provider does. The OEMs don't. Dell doesn't
Right.
make big margins off of Jensen's GPUs. So we can sell it through fairly inexpensively. So it satisfies their grant requirements. But yet, since we sold it, it's easy for us to service and maintain just like it would be a normal cloud.
Okay.
Dedicated inference, on the other hand, that's when we start to move more into startups that are in production,
Right.
Fortune 500s that are delivering something as a service, and they can use that. We can tailor it to it matches their specific application, but they still want to run it. They don't want
Okay.
us running it; they want to run it. And then definitely the inference as a service is absolutely targeting Fortune 500. Somebody who's
Okay.
trying to do production that's multi-region, that has a guaranteed cost. I
Yeah.
mean, one of the challenges with hyperscalers is that the cost is very variable. With us, what they move into the month is what they're going to move out of the month with. So that's mostly targeted towards enterprise. And the more
Okay.
complex the distribution, it's hard to build on-prem for peak if you're running across multiple regions because
Right.
your peak is going to go down and now you've got hardware sitting. And that's
Right.
where we really handle that. We move the workload and we repurpose that hardware for other workloads when it's not doing the real time.
Okay. And is that across sectors, the Fortune 500s that you're working with, or is that across pretty much all
No,
sectors?
it's definitely across sectors. Our ability, we forked the LLM to optimize it for the different hardware platforms. So optimize for AMD, optimize for NVIDIA, Qualcomm, what have you. And
Yeah.
and so that gives us the ability to work both these types of workloads, the real times and the batch, and fill a bigger stack of having the right hardware for the real time, because the real time is the hard one. The
Yeah.
batch is not. The batch that's filling in your holes, that's getting your efficiency from a cloud perspective, that gets our hardware efficiencies up, which is where we're able to lower the price on the real time and
Right.
then, backfill the funnel with the batch.
Okay. And then my last question would be, for 2026, do you have any hopes or ambitions, things that you think are going to be really great in 2026 that are on the horizon?
Yeah, so enterprise adoption is still fairly new. Most enterprises they're finally getting through the POC phases
Mhm.
where they've used one of the models or more of the models to see it does it make them more efficient. Do the employees like having Gemini or
Right.
Copilot or what have you? And
Right.
certainly from a code writing, it's just turned overnight. Where I mean, nearly every company, if you're writing code, if you're doing software development, it's now 70-80% AI doing that. So there was a
Right.
huge adoption. That was like the low hanging, super easy button. We'll
Right.
start seeing more of these chatbots and these supports and these agentic AIs that make people more efficient. But those guys, a lot of the enterprises don't want to do that in the general cloud. They're terrified of their trade secrets getting out.
Right.
So my biggest excitement for 2027 is open source models getting to be good enough that they can be used. You don't have to go to one of the monster models, one of the frontier models,
Yeah.
and or the frontier models start to become available as either cut down open source versions like ChatGPT is doing with OSS, and then, or potentially you get private versions that they allow cloud providers like us to provide a truly private version of ChatGPT or Gemini or Claude or what have you.
Right.
So, and we think that's going to come because the enterprise, ultimately, the customer always wins. And if the
Hmm.
customer says they've got to have something that's private, something that's under their control or an environment they can manage, it's too big of a market. The Fortune 500, Global 1000s, ultimately, that's going to be the big fat middle as enterprises start adopting AI for production.
Right. Well, thank you very much for giving me your insight on these different questions. And I look forward to seeing what's coming in the future with Cirrascale and the open source projects that you're part of.
Great. Thank you very much.
Thank you very much.